What one were we doing last time? That's what we have to do next, is it?
17B2.
Oh, hang on, we have a difference of opinion now.
I think he said version 2.
No, finish B2. B2 or B4? I don't know.
No, we did some before.
What exam am I opening? Which version?
Version
18, 19,
No.
or 17, 8?
Yeah, if you open 18, 19.
Yeah,
That'd be
right.
nice.
18, that would be nice, isn't it? Yeah. 17, 18, version 2. Okay, and which question are we starting from?
B5, I think.
Well, let me see if I can remember from looking at it.
B5 and 6.
We did B4?
No, we didn't. Yeah, we did B4. I have it.
Yeah, we did.
Yeah, I remember the 1 over 32 at the end. So yeah, we're continuing from B5?
Yes.
Yeah? B5? Okay. Let's continue then. So, the first part here looks like a nice probability question. If you have it open there, you can see it. A student has to pass through 2 sets of traffic lights. The probability that he stops at the first is 3/5. Okay, so it looks like here we can either stop, go, and the probability that he stops at the first one is 3/5. So that one has to be 2/5. If he stops at the first, the probability that he stops at the second. Oh, do I have that? Yeah. If he stops at the first, the probability he stops at the second is 5/8. So stop again, 5/8. Go then would be 3/8. If he did not stop, the probability he stopped at the second one is 7/10. So that's 7/10 stop. Go would be 3/10. Right, so I've done the first part. Find the probability that he stops exactly once. So that would be stop go or go stop. So that's 3/5 times 3/8, isn't it? Plus 2/5 times 7/10. So that's equal to 9/40 plus 14/50. Okay, does that simplify into anything nice?
505.
0.505. What is the probability that he did not stop at the second set of lights? What?
Stop, go, and go. No, go. Yeah.
Okay, but he did not stop. Oh, because there's 2 different numbers here. Yeah. So he did not stop at the second set of lights. You're right. So that would be stop, go, or go and go. All right. So that would be 3/5, 3/8, or 2/5, 3/10. So what's that? 9/40 plus 6/50. That's a 9 there.
.345.
0.345. Okie dokie. The student was in fact not stopped at the second set of lights. Find the probability that he was also not stopped at the first. So this is the probability that it was go on the first, given that it was go on the second. That's what they mean when they say in fact. The student was in fact not stopped at the second lights. So what they're saying is, you know that they got to go on the second. What's the probability to go on the first? Now you have the formula for this. That's the probability of go on the first and go on the second, all over probability of go on the second. Now, don't we have this one from earlier? Or we could work it out from the tree. Go and go would be 2/5 times 3/10. Now, what's go on the second? Isn't that our answer we got from number 3? Because go on the second means stop go or go go. So that's our 0.345. So what's that going to be? That's going to be 6/50ths divided by 0.345. Okay, so that will be 0.12 over 0.345. So what's that, about 0.3?
0.3478.
So in fact he was given.
Yeah. In this case, yeah. Yeah.
Is it always what whatever?
That's a long 14 minutes.
I think for these questions they would always use in fact to mean given. So I think the words you're looking for are like, given that, in fact, it is known. Yeah, what else could you have? Provided, perhaps. Yeah, okay, perhaps provided, yeah. Yeah. Words like this. Right. Are we ready to look at B? Yeah? Yeah. Abir, can you see? Yeah. Shall I continue? Yeah. Okay, B. So do you see all they want you to do is to complete the table here? So that's easy peasy. What's x squared? It'd be 1, 9, 36, 49, and 64. You see that? Square the x's. And the next one is xy, which would be 5, 27, 72, 70, and 96. No. 112, not 96. Okay, well that's 2 marks there for that.
It's s squared x. Like
So,
m squared.
What's wrong?
40 times 8, yeah?
Yeah, he said it's 112.
Okay, yeah.
Right, so the next part is they want you to find sx squared. And also they want you to find sxy. Now, these formulas, they're in the formula book. Okay, so we'll just start off with the formula for sx squared. So what is that? That is sum let me think, sum of x squared minus sum of x and then the square on the outside. Yeah, you have it there, Mo. I think this is it.
Over.
Is it over anything? Oh yeah, sorry. Yeah. I forgot to put my over n's, didn't I? So this is this one is over n.
That one is not over. No, the other one is over.
Yeah, this one is over n as well. But
that one isn't.
So all over.
No.
Well, the last one is just the average squared. Yeah. And then the first one, all over n like that.
Yeah.
No square on it.
Yes.
Yeah?
No, I'm sorry.
And root.
Well, it's because they want ss squared.
Okay.
So I'm not going to bother with the root then.
Okay.
So let's calculate this. That minus that bracket squared 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The squares would be 1 plus 9 plus 36 plus 49 plus 64. They've kindly already, can you see in the question, they've already added up the x's for us. Can you see there? They say it's 25.
Sorry, the
Yeah.
formula is wrong.
Which one's wrong?
It's not minus x over n.
Or,
It's minus x, minus the mean square.
yeah, yeah.
Oh, yeah.
That's Stephen, always one step ahead. Right. We got an answer for this? It should definitely be positive. That's 159 over 5, is it? Minus 25.
Yeah.
34 over
34 over 5? Seems fine. Okay. And then the next one is Sxy. Oh, what's the formula for that? That's sum xy, isn't it? Yeah?
Yep.
Over n minus average x over, so average x times average y. Isn't that it? Yeah?
Yes.
So again, let's see. That's a 5, and this time, oh, where's all my numbers gone? That's 5 plus 27 plus 72 plus 70 plus 112 minus 25 over 5 times 50 over 5.
five.
36 over 5. Thank you. These formulas, if you're wondering, they're on page 6. Are they?
Yeah. Page 7.
Page 7.
Top of page 7.
Okay. Now, the reason they asked you to do that is for the next part. So for the next part is they want the regression line, the equation of the line. Now, the formula is in the book, but it's going to be y minus the average. Because remember we said this before, that the average point is always on the regression line. Y minus y bar equals m times x minus x bar. And the formula for m is sxy, which they had you calculate, over sx squared.
What formula is that?
This is for the regression line, the best fit line, the line on the scatter plot.
We have this formula.
Yeah, you do. Sxy, what did we say that was? 36 over 5?
Yes.
And what was Sx? 34 over 5?
Yeah.
So this is 36 over 34. What does that simplify down to? 9,
18 over
18 over 17. Okay. What did we say the average y was? 50 over 5, 10. And what did we say the average x was? 25 over 5. Right. Alright, well, we'll just clean this up a little bit. We will say y equals 18 over 7x minus 5 plus 10. No. No, we will not. 18 over 7x minus 18 over 7 times 5. There we go. Plus 10. Can someone just give me the piece at the end? The
Minus 90 over 70.
what is it? Minus?
90 over 70.
Yeah. Okay. So y equals.
Where?
Huh?
Is it 18 over 7? Oh.
Yeah. 18 over 7 times 5.
7 over 7, no, 70.
Okay. 90 over
7.
7. Like this? No. Plus 10.
Plus 10?
Yeah. I know how to do this part. I want
20 minus 20 over
minus 20 over.
7.
Thank you. Okay. Y equals 18 over 7x minus 20 over 7. That's the line there.
Sir, why do they use in the R for the in the formula book instead of N for the regression?
They use OR?
Yeah, R is equal to SXY over SX.
No, that's a different thing. It's a different thing. It's it's on the next page.
Sure.
Yeah.
This is probably a stupid question, but why did it become 18 over 7 from 18 over 17?
There you go. Oh, rats. Flip.
That was a calculation.
Right. Let's re-get that coefficient at the end then.
But it was 17.
What is it?
80 over
80 over 7.
7. Over 17.
17. Like that. Okay, good. Good. We go on to the next part? The last part, actually. C. Yeah, can I scroll down? This question's a bit tedious, but you're just using the formulas.
Wait, is it positive?
It's positive.
Yes? Okay. C. You're told that the probability of B equals 0.6. You're told the probability of A and B equals 0.36. You're told the probability of B given A is 0.8. And we want to find the probability of A. Well, we'll just use our formula, won't we?
Yeah.
What one is that? P, A, and B equals PA plus PB, yeah.
Plus
Minus.
No, that's the other one. That's PU.
It's the same thing if you
But
just.
you don't have union.
Yeah, no.
Yeah, but we have. But we,
Yeah.
oh yeah, we don't have union, do we? Yeah, because hang on, let's just see. We know this. We know this. Yes.
So
You
we
have
can
it
do
flipped.
the PB.
Yeah, but that's okay. You're saying this and this. Yeah. Yeah, they can be swapped.
There's a formula.
Hang on, just wait a second. We want this,
Yeah.
and do we know this?
No.
No, so we can't use. Oh, because that's what they want next. Yeah. So we'll use the different formula then.
The
Can
second.
we use PB?
Yeah, we'll use this one. So this one here is P A and B
Yeah.
over PA.
Yeah.
That should equal
PB.
0.8.
Yeah.
Yeah, so we can use that. So we have 0.36 over PA equals 0.8. So PA is going to be 0.36 over 0.8. Right, what's that then?
Yeah.
What is it?
0.45.
0.45. Okay, now we can use the other formula. So PA intersect B equals PA plus PB minus PA union B. And that's the thing we're looking for. I suppose I should have started with that. So PA union B will equal 0.45 plus 0.6 minus 0.36. So what's that? That's 1.05 minus 0.36. What is it?
0.69.
Okay. tedious, the question.
The regression line.
Anyways, we have just number 6 left here. B6. Can I scroll down? Yeah? Right. Lentils are sold in bags, and the masses of the bags are assumed to follow a normal distribution with mean 1500 grams and standard deviation of 50 grams. What is the percentage of bags between 1478 and 1522? So they want this area here. Okay? So you know the first step here is the Z transform. So we have to do 1478 minus 1500 over 50. And we have to do 1522 minus 1500 over 50. The Z transform. Yeah. What do you get here for these?
Minus 0.44.
Okay.
0.44.
Nice. Nice.
Yep.
So you have your 2 points now. So in the formula book, what would we have to look up? We'd have to look up the area to the left of 0.44. And then what? What else?
That
Left of the
one right side.
Left of this guy. And then what do we do to the two answers? Subtract them.
Yeah, it's 0.6.
Well, just hold that there for 1 sec.
Okay.
Yeah, that would give us this area.
Yeah.
But can we look up minus?
No.
No, so how do we look up minus?
1 minus.
We do 1 minus. Okay. So that would be twice, whoa, twice the table value of 0.44 minus 1. Now, okay, go ahead there, Mo.
Yeah, the
0.
value for 0.44 is 0.6700.
So that, whatever that is the answer. Now, since they said a percent, I'll write it as 34%.
So what's the Z transform?
Oh, Amjad. Or T F FB. There we go. It's my new one. Well, the FB stands for formula book. Pro tip. Okay. Now, if you look at that question, it is actually a lot of marks. It's 5 marks.
Yeah.
It's 5 marks. So I think I expressed this before. I feel like these types of questions are answered poorly in the exam by students, and they really shouldn't be because there's lots of marks going for them. Okay. The next one for 2 marks. Bags of lentils are packed into boxes of 28. A box is selected at random. Find the probability that there's exactly 7 bags with that weight in it. Okay, so what type of problem is this now? You have 28 boxes or 28 bags, and you want 7 bags. Yeah, so this is binomial. Okay, so you know the formula. It's 28 C. How many successes do we want? 7. Probability of a success? 0.34, because it's continuing from the previous question. Power 7. And then this is 0.66 power. Yeah? Yes? Uh, 21. So they want 7 bags of a particular weight and the rest outside of this weight. And then we just put that in and we get our answer. Should be big enough, I think.
Zero
0.17? 1.00. Okay, so that would be 0.101 then. Yeah? Okay. B. What's wrong, Mo?
I hate this calculator.
You confirmed this answer here.
Yeah.
Yes? Okay. B. In a college, 45% of students catch a cold each winter. During 1 year, a special food is offered to students which is claimed to reduce the risk of catching the winter cold. At the end of the winter, 20 students who had taken this food was selected, and it was found that 5 of these students had caught a cold. State your hypotheses. Alright, so what is the null hypothesis here? Yes. Now, can we get that more as a statement? So we could just say yeah, that the probability of getting a cold is still 0.45. And then the alternative?
It's not.
It's not. Now, is it that it's not? Or is that it's more than? Or is it that it's less than? Well, let's read the question and see exactly what they're saying. So, during 1 year, a special food is offered to students which it is claimed reduces the risk of catching a winter cold.
Less.
Yeah, so they're basically saying that if this works, it means you should be less likely to get a cold. So that's less than 0.45. Yeah. Now again, whoever writes these questions, they're not always very careful about if it's 1 or 2 tails. Which one is this, by the way? What's it called?
B6.
No, I mean, was this 1 or 2 tails? 1 tail, yeah. Let me just see.
I remember when we were checking for the details, we didn't get any details. Yeah.
Oh, okay. There's no point in me checking them
Yeah.
because we know the result. They're practically always 1 tail. Okay, fine. Right. What do I mean by 1 tail? Oh, Amjad. Oh, listen to the pain in your students. 1 tail, 2 tail. You don't remember? We had a good long discussion about this, didn't we? Yeah. So this is 1 tail because it's less than. Yeah.
This is why you should always skip discussion.
No, don't. Because look, this question here is already 2 marks. Okay, that's 2 marks. 1-1. Fine. Now, next one is the test. So, what was our Oh yeah, look, the next one. Nice. It says carry out with 1 tail. Oh, that's good. So that means we know that the previous one we got right. Okay. Right. So, what was the data? We had 20 students, and 5 of them got sick. Was it?
Yeah.
Okay. Now we need to think about what is in the tail here. The 1 tail. So, what would be more supportive of this claim, the alternative? That there were more than 5 people that got sick or less than 5 people who got sick? Less than 5, okay. So, the tail is 5 people got sick and then 4, 3, 2, 1 and no one got sick. That's what's in the tail. Now we could calculate this 1 by 1 by 1 by 1, but remember we have a special table that lets us add these up quickly. Now, we just, wait. Just be careful about what we're saying here. We have n equals 20. Yes? P equals 0.45. Yes? And x is 5 or less. So it's 5. So now, if we look up the table, we don't have to use our formula. We can get it directly from the tables. So this tail will equal what?
0.0553.
553. Now, what do we do if it's more than, clearly this is more than the 5%. So what do we do? Reject or do not reject? We do not reject the null hypothesis. Okay, that's that one done. 4 marks.
Yeah, but shouldn't you add up all the rest?
No, that table that you have there adds them up for you.
Oh, okay.
Remember, it's less than or equal to 5.
Oh,
Ah, yeah, handy. It's handy, huh?
Yes.
You were thinking of doing each one and adding them all up.
Yeah.
What conclusion can you draw? Yeah, we don't have evidence that this treatment works. No evidence. What is it? Some kind of food, wasn't it?
Yes.
Food worked. Okay. And then the last one here, C.
It's like by 0.005.
Yep.
Yeah, very like narrow.
Yeah, but you have to strictly follow the cutoff point of 5%.
So if it was equal to 5%.
Yeah, I think we were talking about this. I think you could. Some people flip a coin. I'm not sure what the most common practice to do is. I don't think it can't be exact. It's going to be hard to imagine it's exactly 5%. So it might look like 5% because your decimal places, there's only maybe a few decimal places. If you calculate it in Excel, you can get those tables that are in your book, you can get them in Excel with more decimal places. Right, C now. So how can we get the P that's missing in the table there?
Add everything equal to 1.
Yeah. 0.16 plus P plus 0.24 plus 0.1 plus 0.32 plus 0.05, that should equal 1. So P would be, do you have it, Mo?
0.13.
0.13. Okay. 2. You're given the expected value. Now you have to get the Q. So that means minus 1 times 0.16 plus 0 times P, which is 0, plus 3 times 0.24 plus 5 times 0.1 plus 8 times 0.32 plus 0.05 Q. That should equal 4.22. So Q is equal to 4.22 plus 0.16 minus 0.72 minus 0.5 minus what is 8 times 0.32, 204, 2.56 is it? All over 0.05. Okay. What's that now? Yeah? 5.6? No? 5.6?
12?
Oh wow.
Yeah, 12.
12, okay. Not 5.6, 12 then. Okay. Part 3, they want the variance. So if you remember, the variance is the expected value of x squared minus the square of the expected value of x. Now that's good because we know that guy, but we don't know that guy. So we'll have to work it out. Oh, okay. 0.16 times minus 1 squared plus 0 plus 0.24 times 3 squared plus 0.1 times 5 squared plus 0.32 times 8 squared plus 0.05 times 12 squared minus 4.22 squared.
$40.69?
40.69?
No, 14.
14.7.
Yeah.
Yes.
And lastly, they tell you that y equals 5x minus 3. What's the expected value of y? That would be 5 times the expected value of x minus 3. So that would be 5 times 4.22 minus 3. And then we have to get the variance of y now in a moment. Say again, sorry?
18.1 for the first one.
Now, does anyone remember what the rule is if you want the variance of this? 25. Yeah, variance of x. So the 5 gets squared, and you don't care about the minus 3. So that will be 25 times 14.7. We worked it out earlier. $367.5.
Yeah.
So 3 significant figures, that'd be 368. Yep. Let's just have a look here at the answers. Was this version 2?
Yes.
Version 2. Right. Can we just go back to 5 for a moment? So, yeah, question 5.
Sir,
Yeah,
one question. Where did that 25 come from?
5 squared.
Where did that 5 square come from?
There,
Yeah,
5.
Equation.
Okay, I see.
What was our first answer for our probability?
50.5.
Oh, 0.505, was it?
Yeah.
Okay. And then the next one was...
0.345.
Okay, and then the next one?
0.348.
Good, okay, that's all fine. And then we'll just jump down to the regression line.
Yeah.
What was it? Y equals...
18 over 17x.
Now they have it as a decimal. What do you say? 18 over...
17.
Yeah. So that's about 1.1, isn't it?
1.05.
Yeah.
06,
Okay.
yeah.
And what about the C?
80 over 17. 4.7.
Good, okay, that's good. And we got 0.69 for the next one, so that's fine. 34% for the bags.
Yeah.
Any answer rounded to 0.1 for the next one.
Yeah.
5.53%.
Yes.
So we
Yeah.
we do not reject the null hypothesis. Yeah. And then P is 0.13, Q is 0.12, variance is 14.7.
Q is 12.
Oh, sorry, Q is 12, yeah. And for the last one, 18.1 for the expected value, and 368
Yes.
for the variance. Yeah, so I don't know what you think about those two questions. They're just very calculation heavy.
So what do they mean by allow follow through?
In which part?
The last part says allow follow through.
So what that means is in the previous line, if you made a mistake, you would lose that M1. You see that M1 there?
Yeah.
But you don't lose the final mark, even though it wouldn't match up to 0.69. So you can, in other words, Mo, you can recover that last mark. Okay. Guys, for class later, what are we thinking? Will we go on to version 3?
Yes.
I
Yeah?
don't have access to
Do? Oh, we don't? Oh, I don't.
have 1 through 4.
Then I don't have it, because I gave you everything I have. So we'll go on to version 4. So for some reason, Young Peng, it means they deleted that version for some reason. Okay.